Hi, so for today we are going to talk about 1001 solved integrals part 21, and currently we are now at number 124. Okay, and for this first problem we're going to solve the integral of x multiplied by 2x minus 1 raised to 7 dx. So in this type of problem we're going to use IBP, or integration by parts. So the priority in choosing U will be algebraic. So in this case both are algebraic, but it's good to let U as x and the du will be dx. Now whatever remains, that will be your dv, and that will be 2x minus 1 raised to 7 dx. So we know that if we integrate that to get both sides, okay, v, okay, so that will be u substitution here. For the 2x, let u as 2x minus 1, and then the du would be 2 dx. So you have du all over 2 as dx. So letting that as u substitution, we have u raised to 8. Then you have du all over 2. So factoring out, we have 1 half. You have 1 half integral of u raised to 8 du. That will be 1 half, okay, u raised to 9 all over 9 plus c, or we don't have to add c, okay, because it's still the v, it's not the final answer. So you have 1 all over 18. Okay, so it's u raised to 7. I'm sorry. It's not, it should not be 8. Okay, I have 7 here, so it should be 7. So this would be u raised to 8. Okay, all over 8. So 1 half times 1/8 would be 1 all over 16. Sorry for that again. 1 all over 16, 2x minus 1 raised to 8. Okay, then now we're going to use the formula uv minus v du. So you have uv minus the integral of v du. So I have the u, which is x. I have the v, which is 1 all over 16, 2x minus 1 raised to 8, minus the integral of v, which is 1 all over 16, 2x minus 1 raised to 8, and then v du, which is dx. So I have dx here. So just simplifying, I'll just zoom it in. So you have 1 over 16 times x, then you have 2x minus 1 raised to 8, minus 1 over 16, factor out, and then integral of 2x minus 1 raised to 8 dx. So using u substitution, you can again get the integral of this. So you have negative 1 over 16. So this will be what? U raised to 9. So that will be u raised to 9 all over 9. Okay, as we are trying to integrate it. But also it has a correction factor of 1 half because of the 2 here. Because if you let that as u, 2x minus 1, again, the du would be 2 dx. We only need dx, so you have du all over 2. That is where the 1 half came from. Alright, so if we do that, okay, so that will be, okay, that will be 1 all over 16x, 2x minus 1 raised to 8, minus 16 times 2, it's 32. 32 times 9 is 288. Then the u would be 2x minus 1 raised to 9 plus c. So this will be our final answer for this first problem that we have here in our 1001 solved integrals. Okay, so let me just reopen my screen. All right, so for the next problem that we have for problem 125, we have the integral of 1 half. Then we have 2x minus 1 plus 1 half. And then we have 2x minus 1 raised to 7 dx. All right. So if we do this, okay, we can just transpose 2x minus 1 raised to 7 in here, so that we are going to have the integral. We have 1 half 2x minus 1 times 2x minus 1 raised to 7, that becomes 8 dx. Okay, then plus we have 1 half 2x minus 1 raised to 7 dx. Okay, so I'll just factor out 1 half. Okay, so this becomes 2x minus 1 raised to 8 dx, plus we have 1 half integral of 2x minus 1 raised to 7 dx. So this is just a simple u substitution. Okay, u substitution problem in here. All right. So you have 2x minus 1 raised to 7 dx here. So u substitution, we let u as 2x minus 1. You'll have du 2 dx. You have du all over 2 equals dx. And then for this second term, we have 2x minus 1. Okay, and then we have du 2 dx. So you have du all over 2 equals dx. So both will be having a correction factor of 1 half. So we have 1 half integral of u raised to 8, and then dx is du all over 2. And then we have plus 1 half integral of u raised to 7, so that we have du all over 2. So that we have 1 half times 1 half integral of u raised to 8 du, plus we have also 1 half here times 1 half, factoring out the 1 half, u raised to 7 du here. So this is just a simple power rule. So you have u raised to 9 all over 9, plus we have 1/4 u raised to 8 all over 8 plus c. So that will be 1 all over 36 u raised to 9. This would be 1 all over 32 u raised to 8 plus c, going back to its original variable, which is x. U is 2x minus 1 raised to 9, plus we have 1 all over 32 2x minus 1 raised to 8 plus c. So hence, this will be our final answer. Alright. Oh, my screen keeps on malfunctioning. I don't know why. Okay, I hope still you get our problem for our second problem. For our third problem, we have 126, and that's the integral of x cubed multiplied by a squared plus x squared raised to 1/2 dx. Okay, in solving this type of excuse me, integral, that was a good one. Okay, in solving this type of integral, x cubed a squared plus x squared raised to 1/2 dx. Okay, so what are we going to do here is we're going to use IBP, but it's not evident at first unless we strip off 1x here. How are we going to do that? We're going to strip off 1x here, so that we have a squared plus x squared raised to 1/2 x dx. Now the purpose of doing that is that so that if we let you this later on in our finding the dv or the v, we're going to have a readily integrable integral. So but for now, using IBP, I'm going to let us right here let u as x squared, and the derivative of that would be 2x dx, and the remaining will be your dv. That will be a squared x squared raised to 1/2 x dx. So how are we going to integrate both sides here? Okay, we're going to integrate to get the v. Okay, hence getting the integral of this whole thing. So if we get the integral of that whole thing, okay, so what are we going to do? We're going to let u as a squared plus x squared. Okay? So in this problem, we know that a is constant because we are integrating with respect to x. So any other variable is considered as constant. And in this case, a is constant. So if we get the derivative of that with respect to x, this a squared becomes 0. Then we have 2x dx. Okay, so that we have du all over 2 equals x dx. We already have x dx here. So now finally we can use the u substitution. X dx will be du all over 2. So now you have 1/2 integral of u raised to 1/2 du. That will be 1/2. Okay, so that will be u raised to 3/2 all over 3/2. Okay, so plus c, or even if we don't write the plus c for now because we are just solving the v, okay, it's okay, right? It seems like I can't erase. Oh, what's happening? Oh, I can't erase. Never mind with that. So if we simplify this, okay, it's just simply getting the reciprocal 2/3, 1/2 times 2/3, that's 1/3. The 2's will cancel. And the u is simply a squared plus x squared, okay, raised to 3/2. So that is our v. Okay, so getting back, we have now our u, which is x squared. We have our v. We can get the uv minus integral of v du. So in this case, our u is x squared. Our v is 1/3 a squared plus x squared raised to 3/2. That's our v, minus the integral of v, which is 1/3 a squared x squared raised to 3/2. Alright? And our du is 2x dx. That is 2x dx. So I'll just simplify first. We have 1/3 x squared a squared plus x squared raised to 3/2. I can factor out 1/3 outside of the integral sign. And there you have a squared plus x squared raised to 3/2, and then you have 2x dx in here. Okay? So I need not to to factor out 2 here. So as you can see, if I let u as a squared plus x squared and differentiate it with respect to x, that would be 0 plus 2x dx. I'll be having a completely du just simply equal with the 2x dx. So that will make my integral very easier to solve or to deal. Okay, so that will be 1/3 x squared a squared plus x squared raised to 3/2 minus 1/3. Okay, integral of u raised to 3/2. And then my du is simply 2x dx. This is that. That's simply du. Okay, so by power rule, I have 1/3 x squared. I have a squared plus x squared raised to 3/2 minus 1/3. This would be u raised to 5/2 all over 5/2 plus c. Okay, simplifying what we got here, that would be 1/3 times 2 all over 5. Then u raised to 5 all over 2 plus c. That would be 1/3 x squared a squared plus x squared 3/2 minus, you have 2 all over 15. Okay, and our u, going back to original u, was a squared plus x squared. So we have a squared plus x squared raised to 5/2 plus c. Hence, this will be our final answer for this problem. Okay, so again, sorry for the little commercial a while ago. I was not expecting that. I didn't mean to sneeze. Okay, I just couldn't help it. Okay, so that's for number 100. I think 120. Oops, is it 125 already? 124, 125. It's 126, I think. All right. So for number 127, we get the integral of x sine squared of x dx. So clearly this is an IBP, and we need to let u as x, and the derivative of that u is simply dx also. Of course, we've got to deal with the dv, which is the integral of sine squared x dx. Get the integral of both sides to get v. But the problem here, sine squared x dx has a half angle formula. Okay? We can translate this as 1 minus cosine of 2x all over 2, then we have dx. So if we just integrate that by sum and difference, we have 1 half dx minus integral of course 1 half cosine of 2x dx. So this is pretty simple. Factor out of those 1 halves. And then we have cosine of 2x in here dx. So this will become 1 half x squared, or 1 half of x, sorry. So 1 half of x minus 1 half. Okay, so how we're going to integrate cosine of 2x? That's u substitution with a factor of 2. So if we let u again as 2x, the du will be 2 dx. So du all over 2 becomes dx. So I have now cosine of u, then du all over 2, factoring out 1 half and 1 half. Okay, I have now this, and it's easily integrable. So we have 1 half of x minus 1/4, and that would be sine of u, of which the u is 2x. Okay, this will be our v, 1 half of x minus 1/4 sine of 2x. That's not the final answer yet. Okay, we have to solve the uv minus v du. Okay, still, so if we're going to do that, the uv minus the integral of v du, so you have the u, which is x, and then the v, which is 1 half of x minus 1/4 of sine of 2x, minus the integral of v, which is 1 half of x, okay, minus 1/4 sine of 2x. Then we have dx. Okay, because the du equals simply dx. So I have dx here. So if we do that, that would be 1 half x squared minus 1/4 x sine of 2x. I just simply distributed the x. And then I have here, of course, I have 1 half of x dx. Okay? Okay. 1 half of x dx minus the integral of 1/4 of sine of 2x dx. Okay? I hope it's still visible. So I'll just zoom in so that it's still visible. So if I do that, that will be 1 half x squared minus 1/4 x sine of 2x. Okay, so that would be integral of x. So that would be 1 half x squared all over 2. Okay, and I have minus here. Factor out 1/4. Again, u substitution for sine 2x. If we get the integral of that, that becomes what? I have a factor again of 1/2 here because of the 2x. Okay, and the integral of sine would be negative cosine of 2x. Okay, I just shortcut it, but it's the same process what we did a while ago. So you have 1/2 of x squared. Okay, we have 1/4 of x of sine of 2x. Distribute the negative sign, don't forget. Okay, so I have negative 1/4, okay, x squared, 1/2 times 1/2. And then I have negative, and then negative here, that's positive, multiplied by a negative, that becomes negative. So 1/4 times 1/2 is 1/8, cosine of 2x plus c. Okay, can we simplify? Okay, yes, we can simplify actually 1/2 x squared minus 1/4 x squared. So 1/2 minus 1/4, that is simply 1/4 x squared minus 1/4 x sine of 2x minus 1/8 cosine of 2x plus c. And this will be our final answer for this given problem. Alright, let me just double check. We just got the correct answer. Okay, so for our last problem, 128. For our last problem, 128, we have y cosecant squared of y cotangent y of dy. So in this type of problem, again, we can just use the IBP by letting u as y, and the du would be dy, and then the dv will be the remaining integrand. So you have cosecant squared y, cotangent y, and then dy here. Alright, so what are we going to do here is that in order for us to integrate this, both sides, so on the left side there's no problem, but in getting the integral of cosecant squared y cotangent of y dy, okay, we're going to use u substitution. So because if we let u as the cotangent of y, the derivative of cotangent is negative cosecant squared y dy, of which we already have the cosecant squared dy here, cosecant squared y dy. So I only have negative du cosecant squared y dy. So if I use u substitution, that will become what? The cotangent y will be u, the cosecant squared y dy would be simply negative du. So I can factor out negative 1, then you have u du, so that would be negative u squared all over 2, and that would be negative u, which is cotangent of squared of y all over 2. So that will be my v. This will be my v. Okay, now going back to the integration by parts, so you have uv minus the integral of v du. So our u will be y, and our v will be what? uv minus v du. So our v will be negative cotangent squared y all over 2. That's our v. Minus v du, that's negative cotangent squared y all over 2. Okay, and the du is simply dy. Okay, here. So just simplifying, negative 1/2 y cotangent squared of y. Negative times negative, factor out negative here, so that becomes positive. I have 1/2 here, so I am left with cotangent squared of y dy here. And again, cotangent square of y is not a readily integrable integral. So hence, we can use the another theorem here, wherein we know that cotangent squared y is simply equivalent to cosecant squared y minus 1. So that I can have here the integral of cosecant squared y minus 1 dy. Alright? So if I do that, I have negative 1 half y. Okay? Cotangent, okay, squared, okay, cotangent squared of y plus 1 half, okay, distributing the integral sign, we have cosecant squared y dy minus dy, okay? So we have negative 1 half y cotangent squared of y plus, I have 1 half the integral of cosecant squared of y. Alright, of course, okay, that will be cotangent y. Okay, and then we have here integral of y, that's, or integral of dy, that's y. Okay, and then of course don't forget to distribute the 1 half here, this 1 half, so that's 1 half cotangent of y. Okay, that's 1 half cotangent of y, and then we have minus 1 half of y plus c. So this will be our final answer for this problem, and I hope you learned something from this video. If you like this video, don't forget to share it with your engineering friends. If you find this video helpful, please don't forget to subscribe to my channel for more content about integral calculus and about engineering subjects. So I have a lot to upload, yet to upload, and make sure to subscribe and click the bell notification there. So again, this is Jei Abat. See you again when I see you. Bye.